Alright, hello everybody. Welcome to the final project for Dr. Ozbay's class. For this project, we'll be focusing on Part A, specifically the Wing 2A, which is the wing with the aspect ratio of 10. In order to do this, we'll be using XFLR5 and finding a couple of different plots, as well as a couple of different values off of XFLR5, and yeah, so without further ado, we'll go ahead and pull up XFLR5. To get started, first we have to get our airfoil designed in, and then get our wing designed in. So in order to do so, we'll go to Module right here, go to Direct Foil Design. For this, we're going to be using the, go ahead and delete that one, so that we can restart here. Alright, so for this project, we are given that we are using the NECA 2415 airfoil with no twist and no dihedral in the wing. So in order to do so, we'll go ahead and generate our NECA foil. So you can go up here to foil, can go down to NECA foils. It'll be, yep, right there. I already have it in since I've done it before, but it'll be the NECA 2415. And for number of panels, just so we have enough values across our foil here, we'll do 250. It's usually set to 100 as a base. So we'll do that. We'll call it the NECA 2415. And we'll go ahead and click enter. And then just so we can see our points across the foil, you can add the style onto it, just so it's easier to see. Okay, next we will go to module. We'll go to XFoil Direct Analysis. Okay, then we'll go to Analysis and Batch Analysis. And for this, we need to have our Reynolds number, which for our Reynolds number, we know that our free stream velocity is 50 meters per second, and that's our chord length is at 1 meter. So you can go ahead and do that calculation, and you should get, yeah, this value right here, 3.33 times 10 to the 6th. And that's good that these ones up here are all preset already. I added this one in, and I added this one behind it just so we have a value behind it. We want polar T1. We want angle of attack. We want a minimum of, should say, yep, right here. Angle of attack should be -5 to 15 degrees with an increment of 1 degree. So you would go ahead and change this to -5, this to 15, and this to 1 degree. Okay, and you want to make sure that this from 0 is deselected. Then you can go ahead and click Analyze, and you should see it start to run. Should take a second once it says analysis is complete. We'll continue on. Alright, analysis is complete. There you go. So you can go ahead and close that, pull back up, and you'll see here we have some graphs of the CLCD, CL and angle attack, a couple of different graphs with our foil here. So we're not trying to get the graphs with the foils, we're trying to do a full wing. So to move forward, we'll go to Wing and Plane Design. And as you can see here, I already have the aspect ratio 5 and 15 already done. But we can go ahead and go to plane, and we're going to define a new plane so that we can have our aspect ratio of 10. So I'll just go ahead and call this AR10. For this project, we only want the main wing, so you can go ahead and deselect the elevator and fin. And then we will look at our main wing here. So you can see we have only the main wing selected. We will go ahead and define that wing. So you can go to define here. We have a chord length of 1 meter. Oops, not 41, that'd be 1. So you can go ahead and set those both to 1. Our offset are both going to be 0. We're going to have a 0-degree dihedral and a 0-degree twist. We want to make sure that our NECA 2415 is selected for both of those. We'll start at Y is 0, and since this is a aspect ratio of 10, it should be, we want to go up to 5, so it'll be 5 on each side. You can zoom out and see it's gotten a little bit bigger. And then over here, just to double check, you can see the wingspan is 10 meters, you can see the aspect ratio is 10, so that's exactly what we want. Now we can go ahead and save our wing there. And we have aspect ratio 10, yep. You can go ahead and save that as well. Next we'll go to analysis and define analysis so that we can get our speed input here. So for this project we are doing, like I said before, this 50 meters per second with a lifting line theory method. So to go ahead and define that, we'll do type 1 as a fixed speed of 50 meters per second right here. And then we will go to analysis and make sure that we have LLT for the wing only selected. So once that is set and you have your velocity here, and you can also double check down here that the Reynolds number is that 3.33 times 10 to the 6th. Just to double check. So once you have this, you can go ahead and click save here. Next, we will make sure that this is the one selected. Okay. There we go. And then we can perform analysis here. So you want to just double check that this angle of attack starts at -5, ends at 15, and goes up in 1-degree increments, just like our project description says here. So once you have that selected, you should be able to go ahead and click Analyze there. And you'll see here for our 10, there we go, just analyze that again. For our aspect ratio of 10, here's our wing, and here's the geometry. You can see that we have the lift, the induced drag, the viscous drag, and the moment selected, so you can kind of see the drag lines, the moment, and that sort of thing there. You can see our speed down here, and this is the overall geometry. I believe that is one of our points for the video. Aspect ratio 10, chord length 1, yeah, the geometry. So this here would be your geometry. Next, I believe, is to plot. Yeah. Okay. So to go ahead and do that, we'll go ahead and click this button right here to go to our plots. And we need the CL versus angle of attack. So for CL versus angle of attack, I already have a graph pre-made right here. In order to do so though, you would just right click on the graph, go to current graph. You can reset graphic scales just to kind of zoom in on the full graph so you get the full length there. And it kind of centers in. To get the CL versus angle of attack, you would go to current graph, define graph settings, and you would select in the y-axis CL and the x-axis angle of attack. So that will be your CL versus angle of attack graph right there. Next, we need the CL over CD, CL over CD versus angle of attack. That'll be right down here. It's the same method. You would go to current graph, define graphic settings, select CL over CD in angle of attack, and you get something like this. Next, we need the CD versus angle of attack. Same method, CD versus angle of attack. You would go through and select your parameters. And then finally, we need the at 5-degree angle of attack. We want the local lift coefficient, induced angle of attack, induced drag coefficient along the span. So in order to do so, we can go ahead and click right up here. And you should see something kind of like this. We can deselect these right here from previous ones. And we can go ahead and deselect that. Since we went at 5 degrees, we'll go to our 5.00 mark here and come across and make sure that we only have that one selected. Just like before, we can go down to Graph and click Reset Graphic Scales so that it refits our graph. And to get started with these, we want the local lift coefficient. So to do so, just like previously, go to Current Graph, define graphic settings. We want local lift coefficient. You would go ahead and click OK. And that'll be the graph of the local lift coefficient. Next is the induced angle of attack. So similarly, you go to Current Graph, define graph settings. We want induced angle. And here is your induced angle. We want induced, and lastly we want induced drag coefficient along the span. So you, just like before, you go to define graphic settings, and you would go to induced drag coefficient. And that'll be your induced drag coefficient. Now, in order to export these over to an Excel file, similarly to how I have these set up for the aspect ratio of 5 and 15, you would go ahead and click here, click Current Graph, click Export, and export it to whichever folder you'd like, and it'll export the values there for you. And just double check we have everything. We showed the geometry. We showed how to get the wing with an aspect ratio of 10. We plotted the CL versus angle of attack, CL over CD versus angle of attack, and the CD versus angle of attack. And we finally stopped with at 5 degrees. We plotted the local lift coefficient, induced angle of attack, and induced drag coefficient along the span of the wing. So that'll be it for part A of Project 1. Thank you for watching.